worked as the head of the Internet Surveillance and Forensic Research Group at King Saud University, Center of Excellence in Information Assurance in Riyadh, Saudi Arabia, for more than over 2 years. Professor Abulaish earned his PhD degree in computer science from IIT Delhi. And after that, he founded the Laboratory for Data Science Analytics at South Asian University, which serves as a central hub for data-intensive, interdisciplinary applied research. His research focuses on development of innovative data mining, machine learning, and network analysis techniques to address real-world societal and industrial problems, particularly for text mining, social network analysis, figurative language detection, rumor detection, sentiment and emotion analysis, health informatics, and data-driven cybersecurity. uh, Professor Abulaish has published more than 140 research articles in international journals, books, and conference proceedings, including many in IEEE and ACM transactions. So very prestigious publications are these. He is associate editor for Social Network Analysis and Mining Journal, and he is assigned to the Distinguished Review Board of ACM transactions on the web for the year 22-24. He served as senior program committee member for various international conferences, CIKM 2022 and CIKM 23. As a member of program committee, he frequently serves prestigious international conferences such as SDM, CIKM, IJCAI, ECAI, PAKDD. So these are very prestigious international conferences, and he has been associated with all these conferences in various capacities. He has also served as publicity co-chair for WI19 and WI20, as well as workshop co-chair for ASO/NM20. He is also a member of editorial board and reviewer for a number of prominent and prestigious journals. Apart from these, he is senior member of CSI, IEEE, and ACM. He is also a life member of ISTE, ITE, and ISA. Apart from all these things, Professor Abulaish is a very prominent resource person, and is a very valuable resource person, and keeps on delivering talks to various international conferences, FDP, and many other programs like FIPs. So with this brief introduction, I would like to request Professor Abulaish to please continue the session. So over to you, sir.
So just to check, am I audible to all?
Yeah, audible, and your slide is also visible.
Yes, sir.
Is it changing also?
Yes, sir.
Yes, changing.
Okay. Okay. So thank you very much for giving this opportunity to interact with very nice audience, most of whom are these faculty members. I tried to have a look on the list. So it's not pure computer science, FDP, rather we have colleagues from mathematics and computer science and some other domains also. So it was difficult to keep me any focus on hardcore computer science research. So I tried to make it as abstract as possible. So if I recall from my teaching days, like either you go for teaching at undergraduate level or postgraduate level, or to pre-PhD courses, we always start from data. And if you teach data at different levels, of course, we try to explain in different way. And even nowadays, we are very much aware about this data science, data analytics, data mining, and so many other mining terms. So I thought to keep this title very abstract and just to explain what is data and what are different domains, where different kinds of data are there, what are the associated challenges, and how these data can be tapped and how these data can be analyzed for various purposes. So this would be the agenda of this one hour talk, starting with basic concept of data, information, knowledge. I will try to explain some domains just to highlight like where data are in different formats. Then I will try to explain what are the inherent issues with data. Then I will come to very basic algo of data mining, just to give a basic hint that how simple mathematics can be used to for very big revolution, you can say. So this a priori algorithm is one example. Similarly, page rank algo is another example, how this some concept from social science came into picture, and how this Lara and Page took that concept and they gave the concept of this page rank algorithm. And that was the basis for founding of Google. And today we know where Google stands. Similarly, Chat GPT, people might have been using this. And this whole revolution came into picture like when it tried to see how this textual data can be converted into numerical form, mainly in the vector form, and how those vectors can be analyzed for various purposes. So the topic is understanding data and its revolutionary characteristics. Before going to this technical part, I would just like to introduce this South Asian University. So we are not very new now because we are 13 years old, but new in the sense just last year we shifted to this Maidangadi campus, and now we are in mission mode to expand it from 500 to 5,000. So we came in January 2023 to Maidangadi 100-acre campus. It's very nice establishment by all 8 SAARC nations, in which India is the key partner, you can say, and whatever other countries, neighboring countries are there, they have share in this operational cost. So earlier we were in Akbar Bhawan, so expansion was almost impossible. We had 7 departments. But now, after shifting to this new campus, from this year, we started BTech Computer Science Engineering, dual degree BTech MTech Computer Science Engineering. Similarly, we were running MSc Computer Science, but now we are going to start, or you can say almost it is announced, this MTech Computer Science also, plus integrated MSc MTech also. So one approach was like those who have done BSc Mathematics Honors or BSc Science, BSc in Science discipline, they can join this 3 years integrated program. They can do MSc followed by MTech. Similarly, in SAARC region, there are various countries who are running 4 years bachelor. So for them, there could be directly MTech Computer Science. So it's very nice opportunity for those who are having BSc degree. They can join this MSc followed by MTech. And those who are having 4 years bachelor, they can join BTech and they can go for further higher studies. So this is just brief introduction of South Asian University, and we are in mission mode. So you can keep on visiting website also, www.sau.int. Soon we are going to appoint faculty members, non-teaching staff, laboratory staff. So we are in mission mode to expand this university as much as possible. In December, Professor K.K. Agrawal, who was founding Vice Chancellor of IP University and who remained there for 10 years, he joined as president of this university, which is the highest post.
सर एक रिक्वेस्ट है सर, लेक्चर बाइलिंगुअल हो जाए तो सर प्लीज सर.
Bilingual in the sense English and Hindi.
हाँ जी सर, हिंदी इंग्लिश.
Okay. Okay. So I was trying to say, like, we got very eminent person, and he is very well experienced, and he has more than 400 publications. He is from computer science domain, and we are hopeful under his leadership we are going to expand very fast. In computer science department, there is laboratory for data science and analytics, and that I am leading. And I myself and some faculty members from outside and some postdocs and some PhD students and some masters, we are the part of this laboratory for data science and analytics. And we are doing some sort of social media analytics and some business intelligence and some sort of cybersecurity. So you can again go to websites and you can try to have a look what are the problems we are dealing with and what kind of techniques we are developing and applying. So this is brief intro about our research lab. Similarly, there are other labs at South in computer science, like machine learning and intelligence, and there is evolutionary computing and networks also. So at current, we are 6 members. Each one is running one specialized lab. And we are hopeful by July, August, we are going to be 12 or more. So hopefully the whole thing is going to be expanded also. So just to come at data. So data is the Latin plural of datum. So datum is basically singular, data is plural. But generally we use data for both purposes, singular as well as plural. And in nutshell, you can say data is unprocessed facts and figures without any interpretation. Like suppose when we started computer science in 1995, it was very like, what is data? And there were so many examples of like railway platform. Uh, People keep on telling what is data, what is information, what is knowledge. So nothing has changed, but of course now data has taken a big shape. So here this data, like whenever you talk about any entity, there are associated features also. Like suppose if you take ceiling fan, this fan has some sort of associated data. So it could be fan type, ceiling fan, table fan, or you can say wall fan. Fan color, this color could be a data, price could be a data, this model could be a data. So basically for every entity, you need to express it, you need to represent it. Like suppose a student, this is an entity. For a student, there could be associated data. It could be name, it could be date of birth, it could be father's name, it could be address. So of course, like in case of fan, you cannot talk about date of birth. So again, it's not blind kind of things. For each entity, you are supposed to identify what are meaningful data that can be recorded. And these are basically lowest level of abstraction. Like suppose for a particular company, per day sale values are there. So these are data values. And over this data, if you try to apply some sort of processing, like suppose you want to try to estimate or determine what is weekly sales figure, what is monthly sales figure, what is half yearly sales figure, what is yearly sales figure. So that with time becomes information, you can say. So at the bottom level, there is data. And if you try to apply some sort of processing, that becomes information. And if you mix some sort of experience, that becomes knowledge. Again, it is difficult to say like where data ends and where information starts, and where information ends and where knowledge starts. So here is one example that I have noted down in this slide. The price of petrol is rupees 96 per liter. So here is basically data. We are talking about price. The value is 96. And the entity is, you can say, petrol. But if you try to note down, the price of petrol has risen from rupees 76 to 96. So some sort of, you can say, like correlation is there. Earlier the price was this, now the price is this. So some sort of information we are going to get. And if you put some experience, like when petrol price go up by rupees 20 per liter, it is likely that bus fare will rise by 25%. So if you put some experience, like if this will happen, then there is probability for happening this thing. So it could be knowledge. So I was trying to say like it is difficult to draw any rigid boundary between data and knowledge and information. For example, if you go to any car company website, they are providing information about the car. What are the models? What are the colors? What are the features? So each car company is providing information about their car, various models. But for a data analyst, if suppose task is what is the best model car, so this person is going to take website of car one, like car one, website of car 2, website of car 3, and they are trying to get all these information. But for this particular analyst, this is basically data. To pull all those data from the websites, then apply some sort of analysis, then you can say this is the best model car. So for car companies, data was information, but for data analyst, all those informations are data. So this is just a little bit about this data information knowledge. So in summary, you can say data as in databases, a spreadsheet, text file. Like if you are writing your biography, my name is this, my date of birth is this, my father's name is this, I do this, so all basically you are recording some sort of data. Information is processed data. If you apply some sort of processing, either aggregation or some sort of calculation, that becomes information. And knowledge is fluid mix of information, experience, and insight. Or you can say knowledge is a meta information about the patterns hidden in data. And here the key point is the patterns must be discovered automatically. Because whenever you talk about data mining or data analysis, you are not talking about 10 records or 15 records or 20 records. Rather, you are talking about very large data, last 5 years data, last 10 years data. Like if you see this customer, this customer dealing companies, like credit card companies, nowadays they keep on sending message. You can get 5 lakh loan, you can get 7 lakh loan without any much hassle. So it's not you can say random message going to anybody. There are so many persons. If you give this offer, they will take the loan and then they will disappear. So basically, they have a lot of data about the persons. They have their past uh, paying history and this expense history also. And based on that, they are trying to offer like this much loan can be given in a very easy way. It's not random. Basically, this is the result of analyzing past data. So the question is, such amount of data cannot be analyzed in a manual fashion. So we need some automatic way to analyze those data. And that's why we talk about this data mining and data analytics and other analytical tools. I hope I am audible, and because I am on this screen, I am not able to see audiences.
Yes, sir, you are audible.
You are audible.
Okay, it's fine. So this data is new aisle of the digital economy. Now people are talking about this is new aisle of digital economy. And if you see the working behavior of companies, like if you are launching any particular product, immediately people are going to social media and they are trying to look into like how customers are reacting. After launch of every product, there is lot of analysis like how customers are behaving basically. How, like, what are the features they are liking, what are the features they are criticizing. So if there are some features liked by the customers, they can be used for marketing purpose. If there are some features that are disliked by the customers, then they can be improved in newer versions. But the point is, if that, and similarly, if you see this election campaign, how much this IT things are there for each political parties, and how much they are investing on this social media and this data analytics part. This there are so many, you can say, very big faces who are getting lot of money just to analyze this data, like what people are liking and whatever policy you are launching, whether people are liking or disliking. So this data can be termed as new aisle of digital economy. But here the crucial point is data must be accurate. Otherwise, if data is not accurate, you are analyzing it. Like when we started computer science, it was very common GIGO property, like garbage in, garbage out. So whatever system you have, and whatever, and no matter how accurate and how big, or you can say good system is, But if suppose garbage is coming, or you can say wrong values are coming, then of course you are going to get wrong result. So there was the concept of authentication and this validation, like whatever you are entering in system, it should be valid, it should be authentic. So data must be accurate. Otherwise, if suppose data is not accurate and you are analyzing it, you are getting some sort of knowledge, some sort of pattern, and based on that you are taking some decision, that decision may mislead you. For example, the last paragraph you can see, this NASA lost 125 million Mars orbiter, and the minor issue was they could not take care of these units, failed to convert imperial to metric measurement. This was minor mistake in the data, and due to that particular mistake, this was the loss amount. So data needs to be correct, and data needs to be analyzed in a proper way also. And if you try to have a look on this traditional versus big data, like in traditional setup, or you can say the old setup kind of things, so we had hypothesis in mind, then you design one experiment, and through that experiment you can get data, then analyze it and try to get the result. If result is not up to the mark as per your expectation, then again you change your hypothesis, or you can say repeat this cycle. So in this process, on left side you can see data was always controlled. But nowadays what is happening? Like there is Twitter platform, anybody can go and join, and anybody after joining can start sending this following some other users. They can start putting post. So data is totally uncontrolled. Similarly, there are various cameras, they keep on capturing the figures. So nowadays we have various processes, various systems, various experiments, and data is being generated. There is no prior hypothesis, and this is called new science of data. So of course, we have huge amount of data, we have varied data, we have dynamic data, but at the same time, there are a lot of noise also. There are a lot of, you can say, outliers also. So this is a basic difference between traditional way of getting data and big data. And you can say each has pros and cons. Like earlier for market survey, people kept on designing some sort of questionnaires, then try to send in to all, and then collect their answers, then capture in your PC, and then try to analyze it. But nowadays, simply go to social media and try to start doing some sort of profiling. You can get billion records about the customers. Then you try to find out their interest group, and then start like marketing or any other product campaign, etc., etc. So it's simply sitting on a machine. You can gather a lot of data, and you can do a lot of analysis and lot of marketing sitting on your PC. So you can say data deluge is there, like data everywhere, nor any drop of insight. So this whole idea of data analytics that is taking a very big shape in this software industry, this is just to how to get insights or knowledge from this huge amount of you can say varied and you can say changing data. So this data science is becoming one of the popular domain for research purpose also and for job market also. And here the challenge is data resides in various modalities. Data are in the tabular form, they are in the form of images, they are in the form of videos, they are in the form of audios, they are in textual format, hypertext like XML pages, or you can say HTML pages, semantic text in which some components are linked together, networks are there, spreadsheets are there, and multilingual, of course, you have Hindi language data, you have Urdu data, you have Arabic data and French data and all the things. And data is enriched in the sense lot of properties can be calculated. Like with data, you can make them weighted kind of things. There could be multiple labels. There could be temporal kind of labels. There could be spatial labels. or you can say each entity may have data that are varied in nature. And of course, dynamic nature is there. Data is not at one platform. Of course, there is a chance of uncertainty, errors, outliers, noise, and data is in terabyte, petabyte scale. So these are, you can say, in terms of representation, in terms of their static or dynamic behavior, in terms of their storage, in terms of their correctness, and in terms of their size. These are the challenges that are associated with data. And these are some domains where you can talk about some sort of data that can be targeted for various purposes. Like in case of bioinformatics, it's very good mix of computer science and this life science domain. And here you can talk about genome data, protein structure, DNA protein arrays, interaction networks, pathways, genomics, similarly systems biology, network biology. So all these are computational biology domain where like lot of data is there, and they can be tapped, they can be analyzed for various purposes. Similarly, in textual, like PubMed is a data set that contains basically research paper titles, author and affiliations, and abstract. So lot of research paper repository is there. And generally we know in abstract part, we try to summarize the whole findings of the research that we are writing, research paper. So abstract is the summary of whole paper. So this PubMed data set, it contains around, or you can say more than 26 million citations of biomedical literatures. So I will show some slide, like if you try to look those literatures, those abstract, and try to find out some fine snippets and try to bring all them together, then of course you can find out some sort of new knowledge that was not recorded in a particular research paper. So one paper was talking about one particular thing, other paper was talking about another particular thing. But if you bring together, it may happen that you are trying to find out something that was neither recorded in paper 1 nor in paper 2, but you got something, some new result. And that could be, you can say, a very useful result that you are getting from 2 papers, or you can say more than 2 papers. So this is one data repository where lot of data is there and that can be analyzed. Similarly, geoinformatics, lot of data, like nowadays this Google map, all the things, you can see how useful they are for common people, for every people. Similarly, in chemistry domain, chem informatics concept is there. And here data are in the form of structural descriptors, topological descriptors, physiochemical descriptors, and geometrical descriptors. All these data can be analyzed for various purposes. Similarly, in business intelligence, if you go to just Amazon website and try to explore some product, so basically during registration, they got some data about yourself. When you are reaching to their website and you are trying to click some product, they are capturing your interest, like for what purpose you came to in this particular website. And in between, you can see within fraction of minutes, or you can say less than that, some sort of recommendations are coming. So basically, these companies have hired third company who are capturing your user data and product data and your clicking behavior. And you are on the website and doing some sort of looking at some sort of product, but on back end, lot of processing is going on. And then they started marketing some other product. Like those who viewed this product, they also viewed these products. Those who purchased this product, they also purchased these products. So basically, this system is not idle. Whenever any customer is coming, one target is, if you are not interested in X, then you should be given the option of Y, Z, P, and Q. And there are various cases, you went for X, you purchased Y, or you purchased P and Q. Similarly, they start offering some sort of discount. If you are choosing a particular product, then they are saying, if you take these 2 together, then the price would be this. If you take these 3 together, then the price would be this. So all these are the challenge, you can say, magic of this data analytics. Like they are having your data, they are having product data in advance, and they are trying to capture your click data. Then keeping all these together, they start some sort of recommendation that is very useful for marketing purpose, or you can say customer retention purpose. Like if any customer is coming to your website, how to retain the customer so that you could get maximum benefit, maximum profit from that particular customer. Similarly, web and social networks nowadays, you can see many people have shifted to the social media for social news. But of course, there are challenges, there are fake news, there are misinformation, there are disinformation. But at the same time, there are many, you can say, breaking news also, many updates also. So it's a paradigm shift kind of things. So and you can realize, like if you take one example of, like, suppose Facebook, you can have a look like how many users are there, then how many, if you think from a graph perspective, the graph is nothing but set of nodes and edges. So if you take users as nodes, then mutual friends as edges, so it's a very nice kind of graph that you can see. Similarly, this graph can be analyzed for various purposes. Similarly, if you take all web pages that are on the web, each page has some link about other page, and if you try to model as a graph, you can easily get a very massive graph, and that graph can be analyzed for various purposes. So we have seen various domains, either physics, or you can say geography, or you can say chemistry, or this business. There are a lot of data is there. But if you talk about challenge, data are not independent. They are generally in the form of graph, or you can say interlinked. So this is one major challenge to deal with data, because nowadays data is not independent, rather they are linked. And here is one example, this iris data set. This is iris flower data set. So there are three types of flowers: iris versicolor, iris setosa, iris virginica. And each flower is described in terms of sepal length, sepal width, petal length, petal width. And there are 50 records for one category of flower, like first 50 are for setosa, next 50 are for versicolor, and next 50 are for virginica. So in this data set, it's very benchmark data set. It's very frequently used in data science, machine learning kind of things. So we have a data set having 150 rows, 150 tuples, and 5 columns, or you can say 5 features. The 4 features are basically sepal length, sepal width, petal 4. And the 5th one is the category. So there are 3 categories. Either a particular tuple belongs to setosa, or versicolor, or virginica. So we have a data set. So basically we have a tabular data set. And here the dimension is 150 cross 5. There are 150 rows and 5 columns. So if you look at this data, each tuple can be considered as a point in 4D space. Just forget about last column, because that is class level, whether setosa, versicolor, or virginica. But if you take first 4 columns, these are numerical values. So for a particular flower, they are recording its sepal length, sepal width, petal length, petal width. So each tuple can be a point in 4D space, 4-dimensional space. So basically, they are dots in 4D space. Then based on their similarity, a graph can be plotted. Like here you can see, we just tried to, I took from this Jackie book. So in this book, they have tried to model this iris data set, tabular data set, in the form of graph. And what they have done, they have taken each tuple as a 4D vector. Then they have tried to calculate distance between, similarity between each pair of tuples. And if similarity is beyond certain threshold, then they are trying to draw this dark line. And if suppose it is below this threshold, then this gray line. So a nice graph, like from that tabular data, you can convert it to graph. And once data is modeled as a graph, whatever graph mining techniques are there, they can be analyzed. Like one application could be like, can this graph be converted into groups. Like, can clustering can be applied here? Is it possible to apply clustering here? So they applied this Markov clustering, and you can see for various, they are controlling this clustering using some parameters. This R is called I'm not going in much detail about MCL clustering. So if R is 1.3, they got 3 nice clusters. And this is actual data. If you go and have a look on this table, your table contains 150 records. Out of 150 records, 50 belongs to one category, 50 belongs to second category, 50 belongs to third category. So they modeled into graph, then they applied this Markov clustering, which is graph-based clustering. And for R equals 1.3, they got 3 clusters. And generally, these clusters are containing flowers of one particular category. And accordingly, if you increase the value of R, you can further categorize it into finer groups. So this is one application, like how this data can be modeled and they can be clustered. Another challenge is how to deal with graph morphism. Like here you can see there are 2 graphs, and you can see number of nodes are there, but structure wise they are they are different. But if you see this graph isomorphism, those who are from mathematics, they might be able to catch this point. Like although number of nodes are same, but you can say structure wise they are different. But from graph isomorphism perspective, both graphs are same. So from a given graph, how system would be able to identify, like all, so you have a data graph and there is query graph. Then you try to find out all subgraphs from the data graph that are structurally similar in one sense. In other sense, that are isomorphic to each other. So these are challenges that needs to be addressed when some people talk about this graph mining or graph analysis. So basically, where are we headed? Into the mouth of scalability and complexity. So either data is in tabular form, or in the form of images, or in the form of videos, or in the form of tree, or in the form of graph. The measure is data is very huge in size. Data is dynamic in nature. Data is diverse in nature. So scalability is one issue. How to deal with such huge amount of data. And second is complexity. Like if suppose for analyzing a particular data, if you are talking about any particular algorithm, that algo must be as fast as possible. Otherwise, whatever hardware advancement we have, it has its own limitations. The way data is growing, the way computational requirements are increasing, and if you try to see the speed of hardware, like processing power increase, it's very behind of the requirement. So we are basically moving towards scalability issue and complexity issue. So emergence of complex data and graphs, they are weighted, multi-level, temporal, spatial features having. They are distributed, uncertain, dynamic, massive, and unbound. And in other terms, you can say networks, and more networks, like omics in systems biology, semantic web, social networks. So mainly you can say like data are not independent. They are in the form of complex graphs. So those who are from maths, again, I can say, earlier we talked about simple graph and some sort of, you can say, self loop and some parallel edges. But nowadays we are talking about multi-attributed graph, heterogeneous graph. So there are data for which we need some sort of complex graph to model them. So there are multi-attributed graph, there are heterogeneous graph, and there are multi-levels graph, and so on. So of course, time is ripe for data science, and due to all those reasons that we have, I have explained, and new science of data, and these are research challenges, research dimensions. Like we need to talk about new data models to model different kinds of data. New mining techniques needs to be identified. Data languages, like we have large amount of data, how to retrieve, like how to answer queries over those data. Similarly, data and model compression, data provenance, security and privacy, data sensation, and of course, now whatever we are going to mine, how to validate it, because that is very important. You have data, you modeled a classification, you learned or developed a classification model, but before applying, you should validate it. We cannot blindly use any model for any purpose. Like suppose there is bomb prediction system or bomb classification system, and suppose it's predicting potato as bomb or vice versa, bomb as potato. In both cases, you can see there is loss. If suppose potato is being predicted as bomb, there would be unnecessary kind of investigation and all the things. And if suppose bomb is predicted as potato, there could be a disaster. So in both way you can say, in either way you can say, there could be disaster. So if you have data and using those data, if you are trying to model any classification system, that you need validation also. That should be accurate up to some extent. Then only you can say whether this model can be deployed for real life applications or not. So knowledge validation, how to validate a particular class of model. So generally you can say this is a very, you can say multidisciplinary domain kind of things that is emerging. And it is going to be a new field at the intersection of data mining and machine learning, database, stats, optimization, algebra, geometry, high performance computing, information theory, visualization, sonification, social, ethical, legal dimensions. Even people are talking about computational social science. There are many papers people are offering and they are talking about computational social science, computational economics. So it's very, you can say this data science is very, you can say multidisciplinary field, and it has a lot of opportunity for research also and for career perspective also. So far we have seen like data in various domain and associated challenges. And of course, you might have realized data is very large in size and very dynamic and varied and all the things. Now let us have a look on our limitations, because for processing those data, like in at SAU also, like my research group, there are other research groups also. Researchers who are working on data analytics, or you can say machine learning part, mainly deep learning algos. They develop some algorithm, then they are applying those algo on data, and they are waiting for result for more than, you can say, weeks, sometimes month or more than month. So whatever machines we have, still we are supposed to wait for 1 week or you can say 1 month to get result. So let us have a look on computing machines and data deluge, like where we stand right nowadays. So this is Hubbard taxonomy of dataset size. Like if you like dataset size, if you try to classify, it could be tiny dataset, a small dataset, medium, large, huge, massive. So tiny in the sense the size is 10 square bytes. It can be recorded on piece of paper. A small in the sense 10 to the power 4 bytes. It can be recorded on few piece of paper. Medium in the sense 10 to the power 6 bytes of floppy disk. It can be recorded there. It can be stored there. Large 10 to the power 8. It requires multiple floppy disk. Huge 10 to the power 10 hard disk is required to store it. Massive 10 to the power 12 multiple hard disk RAID storage kind of things are there. So for storage there is no issue nowadays, but this is different data set size in terms of their descriptions. So it could be tiny and massive. Similarly, for data analysis, we try to develop algorithm, and of course, for each algo, we try to analyze the complexity. So we start big O of root n. It's very ideal case, you can say, very fast algorithm. And generally, we try to go up to big O of n square. But still, you can say there are many various algorithms that goes beyond big O of n square, mainly graph-based algorithms. Similarly, matrix multiplication, you can see. By default, if you just do some sort of programming, you need to apply 3 kind of loops and this goes big O of n square, n cube. And there is some research in this, and there is a Strassen matrix multiplication algorithm, and there the complexity is big O of n to the power 2.78. So again, this matrix multiplication complexity is big O of n to the power 2.78. So it's less than cube, but of course more than a square. So generally, whatever algo you are going to develop, we like not more than n square. So if you just keep in mind massive data set and this n square algorithm, algo having n square, and if you come to this one, like number of operations for algo, if you suppose your algo complexity is n square and your data set is huge, then we need to execute 10 to the power 20 instructions. And this 10 to the power 20 is very, very large number. That means analyzing huge data set using algorithm of complexity n square needs to compute 10 to the power 20 instructions. And now, if you see like performing 10 to the power 20 operations using 10 megaflops machine, a Pentium PC having a processor speed 10 megaflops, 10 mega floating point operations per second. So to process huge data set using algo n square complexity, it requires 317,000 years to process this huge data set using algo n square complexity using a machine of 10 megaflops. If you take further faster machine whose speed is 300 megaflops, it still requires 10 square plus years to process huge data set using n square complexity algorithm. If you take further machine, 4.2 gigaflops, it requires 761 years. If you see this last cell of the table, if go further, 1000 gigaflops, it requires 3.2 years to process huge data set using algo of size n square. If suppose your response time is less than 1 second, then you can see for last 3 cells, there is no as such, or you can say per se, any hardware kind of things. For other, you can see at some cases, personal computer can be used. In some cases, supercomputer can be used. In some cases, workstations can be used. In some cases, teraflop computers can be used. For last 3 cells, there is no hardware existence that can process huge data set with n square complexity where response time is less than 1 second. If suppose response time is 1 week, then for only last cell, there is no such machine. So this we can see like where we stand nowadays in terms of hardware capability. In terms of storage, we have a lot of things, but still in terms of processing, we are lagging far behind. So if you see these data centers that are being developed and that are being maintained, it's very, you can say, large business. So, so of course, the target is to whatever data analytics algo you are going to develop, it should be as fast as possible because hardware has its own limitation, its own pace to develop. So your target should be to develop data mining or data analytics algorithm that should be as fast as possible. So these are some terminologies that I thought I should explain. Basically, data can be stored in various resources. Like data can be stored in database, data can be stored in HTML pages, XML pages, and data can be stored in, you can say, Word file or you can say Notepad file. So basically this Word file, Notepad file, this is example of unstructured source. Unstructured means there is no tagging. My name is this, my father's name is this, my date of birth is this, I do this. So basically you are using natural language to just record your data. In case of semi-structured, we use some sort of this tagging kind of things like HTML tags can be used. Like from here to here it is title, from here to here it is body. Within body there are table, there is row, there is cell. So some sort of HTML tags are there, and using those tags you can identify in this particular document, this is title, this is body. Within body this is table, this is row, this is cell, and within a cell there could be a paragraph, textual things. So that is called semi-structured source. And in table, in a spreadsheet, in database, we have columns, and then under each column we keep on recording, like a student name, father's name, date of birth, address. Then you take one student, record its name, father's name, date of birth, address. Take second student, record second row. Take third one, third row, and so on. So such data are called a structured data source. And depending on where data is stored, if suppose data is stored,
Sir?
yes.
So that if I use Excel and if I store some information, then Excel file will be structured.
Yes, Excel is structured. Yeah,
Okay, sir.
because you are putting the this field's name, attribute name, and then under each field you are saying like this is name, this is father's name, this is date of birth, this is this. So basically every part of that data is tagged. So
And
depending
what
on,
file will go to the unstructured?
yes, Word file, Notepad, WordPad, where no marker is there, they are unstructured in nature.
Okay.
And HTML files, XML files, they are called semi-structured. Like some part is tagged, like there is a tag for defining header of the file. There is a
Yes.
tag for body. There is a tag for defining table. Like here to here is a table. Now within this table, here is the first row. From here to here, so some particular tags are there. So they are called semi-structured. But within a particular table cell, I can write one paragraph. I can store one particular image. I can store one video. So they are called semi-structured. And depending on sources, we talk about unstructured data, semi-structured data, structured data. The unstructured data means data is stored in unstructured sources. Semi-structured data means data is stored in semi-structured sources. And similarly, structured data is stored in structured sources. And accordingly, if you are targeting data, unstructured data, we talk about text mining. If you are targeting semi-structured data for analysis purpose, we talk about web mining. And if you are targeting a structured data for analysis purpose, we talk about data mining. So mainly data mining algo focuses on structured data. So if you see web mining, it requires one particular layer. You take your semi-structured data and do some sort of pre-processing, convert into a structured format. Using those tags, you can identify here to here is the person name, here to here is the date of birth, and this is his telephone number. So from that unstructured, semi-structured sources, you can identify various components, then put in a tabular form and apply data mining. So basically, web mining is nothing but NLP plus data mining. Similarly, unstructured data is there. You apply some NLP techniques to identify person names and company names and numeric values and so on, and put into this tabular form, apply data mining. So these are some terminologies you should be clear: text mining, web mining, data mining. Again, under web, you can see we can talk about mining web logs. Like whenever you go to any website and try to do something, your logs are being recorded. What was your IP address? What was your MAC address? And you went to this particular page, then you went to this particular page. And there are so many crime cases, people that are solved using your log files. Like before doing this particular crime, what was the web surfing pattern of this particular user? Generally, if there is any bomb blast and some people are supposed targeted and some people are identified, then what happens? They try to go and see. Like this, suppose this person was trying to explore these kind of websites, like how bomb can be made. So that corroborate your acts also up to some extent. Okay. So whenever you go to any, you can say, web search engine and try to browse, your logs are being maintained. So if you target analyzing those data, that is called web log mining. Similarly, web pages are not independent. They are linked with each other. One page pointing other, that pointing third, and so on. One graph is being formed. So if you try to analyze that structure, that is called web structure mining. Similarly, each web page has content also. So if you target those content, that is called web content mining. And again, within web content mining, opinion mining and sentiment analysis, advice mining, like those who went to some picnic site, then they start writing some blogs. If you go there, then do this, don't do this. And these are the best things, and they are the bad things, and so on. So advice mining could be there. And similarly, mood mining, other things are going on. So these are some mining terminologies that you should be able to just recall. CS people might be knowing about all these things. So if you see this mining domain, we have started from item set mining. That was the first concept of data mining, or you can say first target of data mining. Then people talked about sequence mining, like this in biological domain, we have genome sequencing, and those sequences can be mined for various patterns. Then tree mining, like this XML documents and ontologies. There are various cases in which family trees are there. So if suppose you have data in which all family trees are stored, and suppose you have a query, like we need to know how many people are having only 2 kids. So basically your query could be a subtree kind of things. One node having 2 childs. This is your query tree. And you have family tree of whole, you can say word. Then simply this subtree can be searched in this database of trees. That is called tree mining kind of things. Similarly, graph patterns mining. We have graph like social networks, biological networks. And so of course you can say we are moving towards more complex way to analyze data. They started from item set mining, then sequence mining, tree mining, and this graph pattern mining. So let us see one like nice example of this item set mining and the point where data mining start. Here the simple idea is there is a superstore. There is a manager. People are coming with their basket and they are taking the items and putting in the basket. The manager is simply looking on their basket. Customer one came, he took 3 items, item 1, 2, 3. Second customer came, item 3, 4, 5. Third came 1, 5, 6, 7, 8, and so on. Now, based on this, suppose you are able to know, like whoever customer purchased item 1 also purchased item 2. Suppose you are able to find out, like for all customers, like you are able to see this pattern, like this item 1 and 2, it was bound by almost all customers. So this is a 2 item pattern kind of things. Similarly, you may try to see which 3 items were bought by almost all customers, which 4 items. Of course, we can go up to n, where n is the number of items in the superstore. There the simple observation is which 2 items were bought by almost all customers, which 3 items, which 4 items, which n items. Now, just to take one example, like suppose you came to know like item 1 and item 2, it is bought by all the customers. Then from market, or you can say from profit perspective, you can reduce the price of item 1 and you can increase the price of item 2. The example is, you can say printer and cartridge. If suppose you are able to know whoever is purchasing printer also purchasing cartridge. Similarly, laptop and this operating system, Windows, you can say. Whoever is purchasing laptop also purchasing Windows. Similarly, milk and butter, suppose bread and butter, or bread, butter and milk. Whoever is purchasing bread also purchasing butter and milk. So in this case, what will happen, like in case of this printer and cartridge, and if you see this marketing of these companies, they try to reduce the price of printer, and they try to get profit from this cartridge. Just to increase this user base, they try to reduce the price of this printer so that people should get it. And once you purchase a printer, you are not going to throw it out after one use. Of course, you are bound to purchase cartridge also. So this is one example. If suppose you are able to find out item 1, item 2 are highly correlated, in the sense most of the customers are purchasing it, then on one item you can reduce the price, on other item you can increase the price to get the profit. Second application could be in the super store, no need to keep item 1 in one corner, item 2 in other corner. Because whoever is purchasing item 1, he or she is also purchasing item 2. So just to avoid rush in this super store, better to keep together. Because if from your data, your pattern says item 1 and item 2, they are highly correlated. They are purchased by almost all customers. So this is second decision, how to manage superstore effectively so that it could avoid crowd and just for crowd management. And third thing, whoever is purchasing item 1 also purchasing item 2. So keep item 1 at one side, item 2 on other side at some distance, not much distance. And if any new thing is coming in the market, you put in between these two. Because someone will purchase item 1 and he or she will go to purchase item 2. In between there is new item, there is high probability he or she will have a look on this new item. So without investing anything, you are doing this marketing also of the new products. So just by using this simple 2 item set or 3 item sets or 4 item sets, you are taking 3 business decision, one for profit making, second for a store management, and third for marketing. So this was the basic idea of this basket data analysis. And based on that, this Agarwal and his colleagues, he is Indian, and he is very, you can say, founder of data mining, you can say, this Han Camber, Agarwal, Jackie, they are top-notch people in data mining. But if you see this, and this based on this analysis, they gave the concept of a priori algorithm. And if you see, I was just talking about Professor Agarwal, I was just looking some speeches. At one place he was trying to say, CS only requires CS. It means computer science only requires common sense. So generally, after having a look on this a priori algorithm, you would realize like how basic thought, or you can say how basic mathematics was used for this a priori algorithm. And using this a priori, the people were able to get all these frequent item sets. Then how these frequent item sets were useful to take informed decision for such businesses. So there the concept was simple, like you can say, the basic concept was, if suppose, so here frequent in the sense, like suppose you have item set means collection of items. So one item set means collection of one item. If there are 5 items A, B, C, D, E, so A, B, C, D, 5, one item set. Then 5C2, A, B, A, C, A, D, it could be 2 item sets. A, B, C, A, B, D, this is 3 item sets. Then you talk about frequent item set. So you decide a threshold. Then whatever item set frequency count, if like suppose AB is a item set, if suppose your threshold is 2. So if this item set is in 2 transactions, you can say this is frequent, 2 or more, it is frequent. If it is less than 2, then you can say infrequent. So in a priori algorithm, the first task was how to identify all frequent item sets. Frequent 1 item sets, frequent 2 item sets, frequent 3 item sets, frequent n item sets, where n is the number of items. Then from these frequent item sets, you can find out association rules, like A implies B, or B implies A, or A implies BC, and so on. So this was basics of a priori algorithm. And here the basic mathematics was, if A is not frequent, then any superset of A cannot be frequent. Like if suppose A doesn't occur in 2 transactions, then AB together or ABC together cannot occur in more than 2 transactions. So their mathematical observation was, if A is not frequent, then any superset of A cannot be frequent. And second observation was, if suppose ABC is frequent, then any subset of this AB, AC, and BC must be frequent. So this was two observations from the set theory, and based on these two mathematical observations, they proposed a priori algorithm, and that a priori algorithm become the basis for birth of data mining field. And nowadays you can see, just you go and have a look on this citations of Agarwal and his colleagues, citation of Zaki, citation of this Hain and Kember. This basic algorithm, the basic idea, and this simple mathematical observations, and how this gave the birth of data mining, and nowadays where data mining are. Like recently there was a case in US, this Professor Jackie was saying when he visited South last year, like there one family was going to a particular super store, and all of a sudden some sort of recommendations started coming, and that recommendation about some items, and that items were related to the birth of related to baby items. The family was surprised why this kind of recommendations are coming to us. They went and asked. The store replied, based on your this buying pattern and the data that we have, we are expecting a baby in your family very soon. That's why we are just recommending it. And they were very much confident, like our recommendation is correct. And finally, it matter went up to court, and finally it was found the baby was supposed to come in the family, but of course, family was not aware about it. So so people have like this particular domain, this recommendation system have reached up to this extent. Like based on your this past data, systems have been developed to be such accurate, having such accuracy. When you just go and check on Amazon also, if you try to explore for product one, then whatever recommendations are coming, you can found in most of the cases, the items are very much related. So it's not random, like you are seeing some this bathroom items and they are recommending clothes. No. If you go and check on Amazon website, you can see whatever items you are exploring, the items are very much related to what you are trying to see. So starting from this a priori algorithm, people came up to this level. And nowadays you can say in this particular 21st century, this data science is one, you can say, a dominating field, both in terms of research and both in terms of career also. Nowadays at many places, people have started MSc data science, or you can say MTech data science. At some places, MTech machine learning and data science. At some places, AI and data science. So it has taken a very, you can say, major domain in terms of career perspective. So these are basic things about association. No need to go, I explained all these things here. So, but here the challenge is, the idea was simply, if you have n items, you take one item sets. Like if there are 5, so A, B, C, D, E, one item sets, then you take all combinations like NC2, then NC3, then NC4. Then in case of 5, you can see like all possible item sets are here. And then for each item set, you just go to your transaction data set, count their frequency. If frequency is beyond given threshold, they can be termed as frequent item set. Otherwise, they can be infrequent. And then from those frequent item sets, you can take some decision. But this number is not as small. If suppose there are 100 items in the store, number of item sets, candidate item sets are 2 to the power 100 minus 1. And this 2 to the power 100, it's very, very large number. And you can realize the idea was very simple, but how complex it was. Generally, in IT, like in real stores, items are more than 100. If suppose there are 500 items, that means you need to check 500 counts. Sorry, you need to check 2 to the power 500 counts, like whether they are beyond threshold or below threshold. This 2 to the power 500 is very, very large number. It's very large number. So after that, you might have seen the lot of research have gone how to minimize number of item sets and how to minimize number of database scan. Because for one item set, you need to read the whole data set, and data set is also large in size. There might be million tuples there, and reading data set is very time consuming process because your data set resides on hard disk. And for reading a particular record, first you transfer your data from hard disk to main memory, then you put into buffer, then try to read it. Then try to check whether A is there or B is there or C is there or D is there or E is there. So one challenge was how to reduce number of items, candidate items, and second was how to reduce number of database scan. So in layman style, you can see, you just see one item set, A, B, C, D, E. Then scan your data set, count their frequency and declare what are the frequent. Then go to generate candidate 2 item sets, again read your data set from first record to last record and identify frequent 2 item sets. Do the same thing for 3 and 4 and so on. In general, you can say if there are n items, you need to read your data set n times. You can say in worst case, you can say. But if you see the research dimension, they started from here and they reached up to the situation in which you require only 2 scan of data set. And there is one algorithm in which you require only 1 scan of data set. The people have started from n scan, where n is number of items, normally 100, 500, 1000, and they reached up to that. So here the major contribution was how to develop this association rule mining algorithm, how to optimize it so that number of candidates should be as less as possible and number of database scan should be as less as possible. So that was the challenge, and that is almost, you can say, matured, or you can say a stabilized field. Like if you are trying to put to develop any algo for this association rule mining, so it's not a good effort because there is no chance, or you can say major chance to further improvement. They have come up to 1 scan, so where you can go further. So this is example of this data set having this four tuples, 5 items, A, B, C, D, E, then frequent 1 item sets, frequent 2 item sets, frequent 3 item sets. So you can have a look on the book also. Similarly, if you talk about mining, graph mining, it has its own issues and all the things. Again, no need to go. This another I would like to highlight, like in computer science requires common sense, is really very justified. If you see this Google company where it is right now, and if you see its founders, this Larry Page and this Brin, they proposed the concept, they proposed this PageRank algorithm. That was the founding algorithm of Google. And if you just try to see this PageRank algorithm, it's very simple mathematics here. It is based on a social theory. Social theory in the sense, like in a room, suppose there are 5 people. Initially, all are having same prestige. All are equally important. But you have to rank the people based on their overall, or you can say final importance. So now suppose in that room, out of 5 people, 1 person knows, or you can say 1 person is endorsing 2 other persons. Similarly, 2nd person endorsing 3 other persons. 3rd endorsing 1 person. 4th another. So in this way, you can find out for each people you can ask to whom you endorse. So maybe 1 person endorsing none, 1 person endorsing 2, 1 person endorsing 3, and so on. So this is some sort of graph. Like here you can see there are 3. A is pointing B and C, B is pointing only C, and C is pointing only A. So in that room, Initially, all are equally important. Their prestige is same, 1, 1. But if you modelize a graph, then suppose I am pointing, I am endorsing 2 people. So initially, all have equal prestige. Suppose it is 1, initialize with 1. If suppose I am, out of those 5, I am the one. If suppose I am endorsing 2 people, the my prestige half going here, half going here. Similarly, there is other person, he is endorsing three other persons. His prestige 1 going 1/3 here, 1/3 here, 1/3 here. So just make a graph. Node levels are 1 and age weights are how many peoples are being endorsed by the source node. And based on that, they now for a particular person, the new prestige is how many people are endorsing him or her. So you take a particular person, like suppose 4 persons are endorsing, and whatever fraction is coming, I have explained. So just add up all those fractions. This will be new prestige. This you do for all the people. And there is mathematical proof. If you repeat this process n number of times, it's going to converge. You can check on the website, Google, like PageRank, convergence of PageRank algorithm. So initially all weights are 1. Then if I am pointing to my weight, my age is being created, and the weight would be half both, 1/2, 1/2. If someone is endorsing 3, directed age will be created, and the weight will be 1/3, 1/3. So once this age is created, you have a graph. Now for each node, just look how many incoming nodes, incoming ages are there, and just add their weights. This will be your new weight, and keep on repeating, and ultimately it's going to converge. And at the end, you can say out of these 5 people, this is the most respectable, or you can say prestigious person. This is second most, this is third most, and this is fourth most. And this concept was taken by PageRank algorithm. And here the challenge was, for your given search query, there are million pages, and users cannot go open those pages and check it. The idea was how to bring most relevant page at first position on first page, next most relevant on second level, next third level, next fourth level. And there is research, generally while using Google, people go to first page only. And on first page also, they generally have a look on first 10, first 20 kind of things. So for a given search query, there are million hits, there are million relevant pages that are being retrieved. The challenge is how to put most relevant pages on first page, starting from first to last. And PageRank, the role of PageRank was only this: how to bring most relevant page documents on the first page. And that gave the birth of Google, and you see where Google is nowadays. So if you see this example, initially A, B, C, they are having PageRank 1, 1, 1. But the idea I explained, if you just like A is pointing B and C, so half 1/2 is going to B and 1/2 is going to C, and B is pointing only C, the whole is going, and C is pointing A, then whole is going. So if you see these mathematical things, and after 6 and 7 step, you can see there is no major change. It's near to convergence. And at the end, you can see this C, the page rank of C, this is 1.15, the highest one. And even if you come to this graph and see why C is the highest one, because it is pointed by A as well as B. A is pointed by only 1, B is pointed by only 1. But C is the one which is pointed by 2. That's why the page rank of C has gone 1.15. But now the question is, A was pointed by 1, B was pointed by 1, but why the page rank of A is higher than page rank of B? Because A is pointed by the most highest one, you can say. That's why between A and B, the difference got created, because A is pointed by C. and B is pointed by A. It takes care of. So this is basically so these scientists, this Page and Breen, they got some idea from social science. They developed this PageRank algorithm, and this PageRank algorithm became the basis for establishment of Google. And now you can see where Google is. So very simple mathematics that can be used for various, you can say revolutionary kind of things. Similarly, third example, the one I gave at the beginning, this PubMed data set. So this is some key snippets from various research articles. Stress is associated with migraines. So in one particular research, it is recorded stress is associated with migraines. In second, it is recorded stress can lead to loss of magnesium. And third says magnesium is a natural calcium channel blocker. And fourth paper says calcium channel blockers prevent some migraines. So here are simply snippets, but if you bring all these together in the form of a semantic net kind of things, so we have stress, we have magnesium, we have migraine, we have calcium channel blocker. We simply modeled as a semantic network. The stress associated with migraine, this was basically the first sentence. Stress lead to loss of magnesium, another sentence. Magnesium is a calcium channel blocker, third sentence. And calcium channel blocker prevents migraine. So if you bring these snippets in a particular network form, then apply network analysis techniques. From this particular network, it can be analyzed. It can be inferred magnesium deficiency may play a role in some kind of migraine headache. So this particular inference was not recorded anywhere, but some key snippets were recorded. If you bring all those key snippets together, then go for network-based analysis and inference. Whole mathematics is behind it, how to go for inferencing. Then you can find out some knowledge that was even not recorded in any research paper. And there, this Swanson and his colleague gave the concept of LBD, that is literature-based discovery. They gave the concept of literature-based discovery. And in their example, the case was this particular chemical is found in this particular fish, and this particular fish is useful for this particular disease. So there were two research outcomes. In one case, this particular chemical is found in this particular fish, and this particular fish can be useful for this kind of disease. Then they inferred something, then they coined it. Like this chemical can be used for this particular disease, and then they went to wet lab, and there it was tested, and it was found true. And there it was coined the concept of LBD, that is literature-based discovery. Nowadays, there are so many databases like nowadays this Google Scholar. It's maintaining your research papers in their repository. So if you bring all these textual data together, and then try to model it, of course, in the form of some sort of graph, and then you apply some graph mining techniques, lot of new insights, lot of new knowledge can be identified, can be found. And nowadays, this whole business intelligence and this whole, you can say this cyber security, database cyber security, all these are taking shape just based on data. This whole chat GPT, if you go and try to see the mathematics, basically they are able to encode this textual data in the form of some numeric one. And then some sort of this vector space, some distance measures, some similarity, they are able to predict if these are the words, then what would be the next word? Like this language generation kind of things. So this is possible only because we have large amount of data, and we have got the way to model this data, and then analyze this model to answer for language translation, for language generation, and for various, you can say, like this image generation and this various application domains are there. So all these, like most of them are basically based on the way we are analyzing data, and this is basically feasible due to this mathematics that is working behind it. Of course, GPU is playing major role, otherwise, because it is enhancing your processing capability up to many many folds. So that from game theory it came into picture, this GPU kind of GPU based computation, and based on all these, we have, like, whatever these systems are coming into market, why they are so accurate? They are able to answer all the queries because they have tried to capture most of the data, most of the knowledge data on web. So they are capturing all them together, and they are able to model them, they are able to correlate them, and they are able to process them to answer your queries or to answer your questions. So this is mainly feasible due to this huge amount of data that is being stored and that is being modeled and that is being analyzed behind the scene. Like if you see this chat GPT various versions 1, 2, 3, 3.4 and 3.5 and 4, and if you see their parameters they are using, billions parameters they are using. So basically, you have nowadays like models that are using billion parameters. So basically, all knowledge that are available on this web, they are being captured in a way so that they can be analyzed and they can be used for some sort of inferencing purpose. So this is like some basics about data analytics and data, and some motivational things like don't consider any idea as a simple idea. And you take the example of a priori algorithm, and take the example of page rank, and take the example of LBD. They were very simple idea initially, but how they gave the birth of establishment of such a giant company, establishment of or a start of such a new field which is becoming revolutionary. This data science, data analytics, data mining, all came from this data mining. So this is what I wanted to talk. So in short, if you try to summarize it, so data analytics is one of the trending technologies for 21st century. Data analytics is one of the key enabler technologies for a smart computing. Nowadays, this data translation, NLP, all the things. Efficient data gathering, data cleaning, data storage and indexing, data analysis, data visualization techniques needs to be developed. So all these are, you can say, individual research areas. How to gather data, how to store it, how to clean it, because data is uncontrolled. There are a lot of noises, outliers. They are not edited. How to store them, how to create indexes, how to analyze, how to visualize. And major application areas are open source intelligence. Many intelligence agencies are using like this data that is in public domain. Data-driven cybersecurity, business intelligence, information assurance, like fake news detection, rumor detection, predictive modeling, and so on. So these are very, you can say, promising research areas where one can try to explore. And of course, there is a lot of career opportunity also that can be explored. So we can stop it here. If you have any questions, you can ask. And for looking into some research work that we are doing at this LDSA research lab, this URL is there. You can have a look.
Sir, can I ask something?
Yes.
Am I audible, sir?
Yes. Yes.
So you discussed about the various spectrums of data mining. I think somebody is, unmuted. Okay. Am I audible, sir?
Yes. Yes.
Yeah, first of all, very good afternoon, sir. It was a very interesting and a very contemporary, useful session. So thank you so much for enlightening us. One of my major areas of concern is that you spoke about the various spectrums of data mining, and nowadays, a huge amount of big data. My one observation, maybe I would like to seek your expert opinion in that matter, is that huge amount of data also can be a great problem of concern. We discussed about that. So
Great
how
problem of great problem.
I think somebody is unmuted. Okay.
Yeah.
So I just wanted to know that there has been a great deal of discrepancy, in regard to the huge inputs of data that we are taking in, and what is the kind of output and the outcome that is being generated, because that, at times, not at times, because we are not so much ready and prepared to the management of these huge and big amount of data, so it results into all kinds of blunders and mistakes and errors. So at times, many of the times we see that how all these algorithms and the techniques, how they are being feeded. In my layman language, I'm not such an expert at all in this area. And then how do we draw the conclusions? So that may not be always exactly accurate. That is something which is very, very significant and important, because the last line which you said about is that the particular subject opens up various research areas also. So how are the organizations or maybe the brands which are specifically using this data? So procurement and drawing the output in the right direction. It's a wonderful technology, but then what are the serious areas of concern in the case of management? That is a very important thing. And the second thing is that, a certain data which goes to them, which we are not even authorized them to do that. No. So, without any kind of authorization and the privacy and the security part also, we are going and visiting the malls and the retailers, taking out all such kind of information. So is there any kind of a check and balances in regard to that, sir?
Okay. So basically, with abundance, of course, the challenge is there. The data is that I explained earlier also, like all these noises, outliers, and this. Even in some sense, if you see this sarcasm also, like even
Right.
though it's not noise, but I am using some good word, but I am sarcastic in nature. Suppose, oh, you are great. So this great I am not using as a positive, rather I am taking as a sarcastic. So this challenge is always there. So whenever you talk about KDD, that is knowledge discovery from data, and if you just try to have a look on pipeline,
Right, sir.
before analysis, there is a long, or you can say there is a good number of steps, which mainly focuses on what kind of data and how to deal with noise, how to deal with inconsistency, how to deal with some other issues, or you can say missing values and so on. So this is always there. So before and this garbage in, garbage out is still extends today also. If
Right.
suppose data is not accurate, your result is not accurate, whatever analysis techniques you are applying. So one aspect is, before going for analysis, you have to make sure, like whatever data is coming, whatever techniques you go, you try to adopt, it's up to you. But you have to make sure data is accurate in nature. Like suppose for a particular product, of course, if you go and try to see what people are saying, so there might be your competitor also who are intentionally saying this camera is your camera is not good, your phone is too weighted, and so on, so and so on.
Right, sir.
So this is another challenge to have a look, like out of so many tweets, who are spammers, who are non-spammers, or you can say who are legitimate. So this data pre-processing challenge is always there, and of course, before any analysis task, you are supposed to take care of data pre-processing. Otherwise, the whole thing is going to be, you can say, misdirected. As far as this privacy is concerned, generally, if you go to Twitter and Facebook, there is a way to set your profile, what data you want to make it public, what data you want to make it private. It means whatever data I can access on Facebook and Twitter, they are in public domain. So from that perspective, they can be used. But of course, if something is coming with name, so there is a concept of like even hiding those details also, we can do this. But assuming whatever data are on Twitter in public domain or social media, they can be and they can be, you can say, taken, they can be analyzed, and they can be used. Otherwise, you have the way to make it private. If you don't want to disclose your like location, your age, or other factors, you can make it private.
Right, sir. So, the filtering of the data also,
It's very important, very important.
and secondly, the question also arises, how do we check the accuracy of the data? Right now, you give an example also. So some people, giving the fake perception, fake opinion. So no matter, we can be an expert in analyzing it. But then how to know that, the psyche of the people and the perception and the mindset of the people. So if we are getting the wrong data, so the analysis can also turn out to be completely, wrong, inaccurate. So that can remain a issue of concern.
Again, this is indeed an issue, and if you just try to have a look on this spammer detection,
right, sir.
There is lot of work on that part also, spam detection. So all these are like why we install this antivirus on your PC, because with software there are a lot of viruses also.
Right.
So in social media also, it provides opportunity, but at the same time, there are so much spam messages. There are so much, you can say, redundant messages. There are so much, you can say, noisy messages. So there is parallel work to look into all those things so that you would be able to say these are spammers, these are spam messages, and then you can focus on only those that are of useful to you. So for a data analyst, the major challenge is how to take relevant, or you can say authenticated thing from those. If it is controlled, of course, whatever you are going to get, this is authenticated. But if it is uncontrolled, then this is your challenge, or you can say this is a challenge for system analyst, data analyst, to look into all these aspects. Before feeding into analytics system, you need to have a look on all these aspects, and then you take the one that can go to this system, and based on that, whatever knowledge is coming, whatever patterns are coming, that can be relied on.
Right, sir. Thank you, sir. Thank you so much, sir. Thank you, sir.
Thank you, sir.
Thank you so much.
Hello.
Yeah.
Sir, I want to know whether there is any existing tool that exists for detecting fake news or rumor detection. Thank you, sir. Thank you so much.
As such, tool I don't know, but research work is there.
Okay, sir. So no, presently there is no such tools that can detect fake news.
No, there should be. It's not in my knowledge, but of course, if you go and search, definitely there could be. This I can say.
Okay, thank you, sir.
So if you try to see on Google, there could be some tool. They might be up to some extent, like this for plagiarism checker. Authenticate is one, iTernit is one, but there are so many online tools also. They try to do this work up to some extent.
Okay, sir. Thank you, sir.
सर एक क्वेश्चन मेरा भी है
जी बताएं
सर। ये अभी वेक्टर डेटा की आप बात कर रहे थे। ये वेक्टर डेटा जो है मेरे पास एक्चुअली तो बहुत ज्यादा एरिया और स्पेस कंज्यूम करता है। अगर मैं इसको रास्टर डेटा में कन्वर्ट कर लूं और फिर वापस मैं वेक्टर डेटा में कन्वर्ट कर लूं, इज इट पॉसिबल?
बिल्कुल है
सर। वो डेटा लॉक होने की बात होती है।
जैसे आप अगर क्लाउड कंप्यूटिंग की बात करें, सपोज आपके पास दो ही फील्ड है, एक्स एंड वाई,
राइट,
और उसके अंदर 1 बिलियन रिकॉर्ड्स हैं, 1 बिलियन ऑर्डर्ड पेयर्स आपके पास हो गए, एक्स वाई वैल्यूज हैं। आपको ये ट्रांसफर, और सपोज कर लें कि 1 बिलियन टपल्स हो गए, हर टपल के अंदर 2 वैल्यूज हो गए, एक्स वैल्यू, वाई वैल्यू, और एक्स वाई वैल्यू को स्टोर करने के लिए सपोज 2 बाइट चाहिए आपको इंटीजर के लिए, सपोज इंटीजर वैल्यूज हैं या रियल वैल्यूज हैं। इट मीन्स हर टपल की साइज 4 बाइट हो गया। आपके पास 1 बिलियन टपल्स हैं, तो 4 बिलियन बाइट्स इट्स नॉट ए स्मॉल साइज। अब इस डेटा को आपको स्टोर करना है क्लाउड पे, तो इतना ह्यूज साइज वहां ट्रांसमिट करना, फिर वहां भी इट्स वेरी चैलेंजिंग टास्क, इट विल टेक मच टाइम। द अदर वे कुड बी, if you are able to identify a mathematical model like this, xy data is nothing but y equals x square plus 1, where x is a natural number. So you can simply pass this model to cloud, and there for each natural number you can generate y value. So it is always possible to compress your data and recompress your data depending, but if you are able to find out such model, if like this whole regression line estimation, you can see you have data. Using this data, you are trying to find out a line that best fit to your data. Then using this line equation, you can regenerate your data. Basically, you had data. Using this data, you estimated the equation of line. Then you store all these parameters. Then using this equation of line, you can regenerate your data whenever you want. So this raster and vector is always possible, of course, if it is going to help you to reduce data set size.
But sir, if converting our data into raster, so when we convert into the vector, obviously we will lose some data.
Yes.
In the like at the time of conversion in the raster graphics generally.
This is always there, like even in the case of regression line. If suppose you
How
had
we
data,
maintain our data before, like when we go converting our data into the raster things, so we have to maintain our data and quality and all that. So is there any application available in our cloud and all that?
As such, no, you are trying to know like any application that will convert your data into raster, and without losing anything.
And suppose sir, vector file, vector data is near about 100 MB, and when we convert into the raster, automatically the 5 MB, just convert into the 5 MB. So again, in future, if we want to again convert into the vector, so it's a very challenging job.
Obviously. So we have not done in that direction, but those who have done in that, like how to convert this vector into raster and vice versa, and how to maintain data integrity, or you can say data completeness. So there could be a way to deal with this, but our research is not in that direction. We mainly focus on textual data, then try to model in some sort of graph and some other structured format. Then to analyze them, we try to develop some algorithms.
Okay, sir. Thank you. Thank you, sir.
Any other question?
Thank you so much, sir.
Okay, thank you.
Thank you so much, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you so much, sir.
Okay,
Thank
thank
you.
you. So
Thank
we
you
can
so
stop
much,
it
sir.
here. Okay.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you very much, sir.
Thank you very much, sir.
Thank you, sir.
Thank you, sir.